entramos acá en el marco si nos ponemos...
Buenas noches a todos y bienvenidos a una nueva edición de un final de Integración 4, de cuarto año de la carrera de Ingeniería Química en la Facultad Regional Delta de Campana, de la UTN. En esta oportunidad me complace muchísimo presentarles a unos alumnos que van a dar su especie de tesis final de la materia Integración 4, que es una especie de resumen de todo lo que pudieron haber aprendido en el transcurso de su cursada de la carrera, y es el inicio de lo que están terminando en Integración 5 como proyecto final de la carrera. Así que, sin más que decirlos, bueno, agradecemos acá a los parientes, amigos, a la directora Liliana Romero, y a otros colegas que también después prometieron verlo por YouTube. Así que los dejo con los protagonistas. Todos ustedes.
¿Qué tal? Buenas tardes. Bueno, gracias por venir. Nosotros somos Lara, Melanie y Lorenzo y vamos a hablar sobre un proceso de captura, purificación y liquefacción del dióxido de carbono. Bueno, es como mencionó Luis, el final de la materia Integración 4. Y bueno, para empezar vamos a dar una especie de resumen de lo que fue todo el proyecto en inglés. Debería ser en inglés, pero bueno, para los que no manejan el idioma, quédense tranquilos que todo lo que vamos a decir en inglés se va a volver a repetir en español más adelante.
Mucho más detallado.
Arrancamos con la...
Well, hello everyone, nice to meet you. My name is Melanie and they are Lara and Lorenzo, and today we are going to talk about the CO2 capture, purification and liquefaction of technology. The main objective of this presentation is to show you environmental, technical, social and economical aspects of the design and the installation of the plant of this type in the country. So I hope you like it and thank you for being here. As you can see in the table of contents, our presentation is divided in 6 chapters and I am going to start with the introduction. First of all, it's important to talk about carbon. And what is carbon? Well, carbon is an essential element for life on Earth. It's basically in the air we breathe, it's in the oceans, in our bodies, it's in the industrial emissions, so basically it's everywhere. And well, how is possible that the carbon is everywhere? Well, it's because of the carbon cycle. That is a cycle it's a cycle that consists in a sequence of natural chemical reactions that explain how the carbon is transferred from one reservoir to another, as you can see in this picture. Although this cycle is naturally balanced, the human is upsetting this balance because of the CO2 emissions through the activities as burning fossil fuels, for example. And the main problem of this is that the CO2 is a greenhouse gas, so it has the ability to capture or trap the heat of the sun and warm the atmosphere. And as a summary of what I have said, because of the increasing energy demand and the human activities, we have every time more and more greenhouse gases emissions, as the one mentioned there, and these gases accumulate in the atmosphere. So, as you can see, the contrast between the pre-industrial revolution levels compared to the levels we have today. And what are the direct consequences of this? The increasing in the global temperature and changes in global climate, as you can see, the loss of species, the more severe storms, and the rising sea levels, just to mention some of them. And well, how is the situation in the rest of the world? Well, we have a global context in which we can mention the top 5 CO2 most emitting nations, which are China, United States, India, Russia, and Japan, and all of them have in common that the usage of fossil fuel as the primary energy source. And then we have our country, whose power matrix is 86% fossil fuel based, and it's in the 31st position in the global ranking that I have mentioned before. So, the question is how to fight the climate change. Well, there are many things that we can do, but first of all, the society have to be very compromised with building resilience, with adaptation and mitigation actions. We have the 17 Sustainable Development Goals established by the United Nations that are great examples of adaptation actions for the societies. And then we have the international climate agreements, as the Montreal, the Kyoto, and the Paris agreements that are examples of mitigation actions that tend to mitigate the impact of our activities in the earth. And just to mention an example of a mitigation action, there are several techniques like this one, like the carbon dioxide removal techniques. For instance, the carbon capture project, like the one that we are going to explain today.
So, in this chapter we are going to talk about the market study.
Okay.
About the market study. So, regarding the carbon capture project, we find two types. CCS, carbon capture and storage, CCU, carbon capture and usage, and CCUS, carbon capture, usage, and storage. So what is the difference between these three? The first one, carbon capture and storage, involves the capture of CO2 in source like power plants or industrial facilities that use fossil fuels. And if it's not being used on site, the CO2 capture is compressed and transported by pipeline or ship to be injected into deep geological formations. And the second one, carbon capture and usage, involves a range of applications through which CO2 is captured and used. Can be directly for engagement recovery or indirectly transformed in products like synthetic fuels, chemicals, and building aggregates. Our project is going to be in this area. So, we are going to analyze the global and the national market. It's really important to say that we have two different approaches. One as a CO2 capture company and the other one as a CO2 production company. As a CO2 capture company, we have a developed market in the European Union. These companies were found between 2005 and 2009. One of the most main companies in the global market are carbon capture, Grinding Works, and Carbon Clean. So as a CO2 production company, about 230 million tons are used in the world every year, and there is a recent market with the new usages of CO2 as a raw material. So regarding national market, as a CO2 carbon capture company, we are going to be pioneer throughout the country, and as a CO2 production company, we have risk demand and imports.
So what can we do with all this CO2 that we capture? We have 4 emerging markets that we want to put the focus on, which are the 4 shown on screen. These are e-fuels, chemicals, construction materials, and greenhouses. And now we're going to give a brief of what these markets are trying to do with all the CO2 capture. So the first market is the e-fuels, which is basically capturing CO2, using captured CO2 from an industrial source, or it can be also from air capture, and it's also using hydrogen that is produced with renewable energies to produce fuels such as methane or methanol. Then we have the chemical industry, which is trying to replace fossil-based raw material with CO2 to produce polymers, and that is used to produce then plastics, foams, and resins. The third market that we have is the building materials market, which is trying to replace water with CO2 in a technique that is called concrete curing, where the cement reacts with CO2 to give the concrete that is used for building materials, roofs, and everything that is used for building, the building industry. And the last market that we have is the market of greenhouses, the use of CO2 in industrial greenhouses, which is trying to replace the CO2 that is used nowadays from fossil-based raw material with CO2 that is captured.
So, with our project, we use two more projects in our country. We choose CO2 pure concrete aggregates and fuels. Why? Because CO2 pure concrete is the cheapest one to produce and has the biggest climate benefits. And fuels have high demand and use a lot of CO2 for their production. So, our target is to capture the 30% of the emission of a power plant. This is equivalent to process that amount of flue gas, and without we are going to produce 45 tons of CO2 per hour. So, what we are going to do with our productions? We decide that with 10% of the production we are going to supply the CO2 industrial grade. With 80% of the production we are going to boost the methanol production in our country, and with the last 10% we are going to boost the CO2 pure concrete production in our country. Well, in this chapter we are going to talk about the technology. There are three ways of separating the CO2 from the other gases, but only one of them does it without altering the process, and this is the post-combustion. It involves the CO2 is separating from the flue gases by using a solvent and with a process of absorption and desorption that Melanie will explain later on in the presentation.
So now the fourth chapter is about location. We have to wonder what are the industries that emit the most greenhouse gases, so we can use those emissions as our raw material to produce the CO2, to purify the CO2. Well, the sector that produces the most greenhouse gases is the energy sector, which in Argentina produces 51% of all the greenhouse gases emissions. Inside this sector we can find the fuel production and the electric power production, which globally the fuel production represents between 5 and 10% of all the global emissions, and in Argentina it represents 5% of the emissions. Meanwhile, the electric power production represents 40% of all global emissions, but in Argentina is the 25% of all the national emissions, which is still low. So we will focus our analysis on those mentioned industries. So now we have to think about where are these industries located in our province. So we seek for 2 refineries and 2 power plants. The YPF refinery that is located in the city of Ensenada in La Plata, Action refinery in the city of Campana, San Nicolás power plant in the city of San Nicolás de los Arroyos, and Manuel Belgrano power plant also in Campana. So after an analysis that we will explain later in the Spanish part, we chose that the better location for us is the Manuel Belgrano power plant located in the city of Campana because of four main reasons that are the access to constant flow of CO2, near big industrial posts, so we can have clients, technical schools and universities to where we can find skilled labor, and this facility also is near roads and ports.
Well, in this chapter we are going to speak about a little bit about the process, and just to mention some characteristics. First, we have its modular concept. That it means that we can maximize cost efficiencies and reduce the time required for installation and the startup. Then, the easy on-site connection to the client's feedstock supply. That is directly connected to the stack of the client. Then, just to spoil a bit of the process, it includes two main stages, which are the CO2 capture and purification, and then the liquefaction part. And this process allows us to obtain industrial grade CO2 with more than 99% of purity. Well, here you have a black box analysis, which is a simple analysis of the process with the interaction of the inlets and outlets. First, you have one inlet, that is the flue gas, that is our raw material, and then three outlets, the effluents, the liquid and the gaseous, and the CO2, that is our final product. And on the top, you have the relation between the inlets and outlets that tends to explain how there is no accumulation in the process and that everything that goes in then gets out. And here you have the block diagram of the process that tends to summarize and explain a little bit more the 6 main stages of our process that are: first, the capture and pre-treatment of the flue gas, then the CO2 removal unit where we obtain the CO2 from that gas, the purification zone, the compression of the gas, the makeup and the drying of the gas, so it means that you can remove the humidity that is present, and the liquefaction and storage part. First, as you can see, we can follow the chart. The flue gas of the stack of the client is captured, then to be scrubbed in the scrubber, where the CO2 and the SOx, these are impurities that are in the gas, are removed. Then this gas goes to the CO2 removal unit, where the CO2 is captured from this flue gas to be processed in the rest of the process, and then the flue gas without CO2 leaves the top of the tower to the atmosphere. This CO2 is captured by a solution, as Lara mentioned before, a solution of a solvent called MEA, which is here. This solvent, this rich solvent with CO2 regenerates in the dissolver, and we obtain the CO2 that is our main product. Then is the step 3, that is purification of this product with 2 washing towers that are also scrubbers. As the first one, we wash this line, this gas, and remove every impurity that was left. Then is the compression part, the drying, the makeup and drying part, where we remove all the humidity that was there, and then is the final part, that is the liquefaction and storage part, where the CO2 is cold, and then is liquefied and storage in the tank.
So now we have the last chapter, which is NCA. NCA means Environmental Complexity Level, which comes from the Spanish Nivel de Complejidad Ambiental. This is regulated by the law that's shown on screen now, that law. This law establishes 3 types of industries. that we can find in Buenos Aires province, according to the danger that they can cause to the population and the environment. The first category is for establishments that are innocuous and does not constitute a risk for safety, health, and hygiene of the population. The second category are establishments that are uncomfortable and constitutes a nuisance for the health and hygiene of the population. And the last and the worst category is the third category, that is for establishments that are considered dangerous because they constitute a risk to safety, health, and hygiene of the population, and also can cause serious damage to property and environment. So how do we calculate it? Well, in Annex 2 of Decree 973/2020, there is a formula that establishes 5 main factors that we can give a score, so we can have a final score of the NCA where we will establish the category of our company. So these are the 5 factors of this equation. The first one is related to the classification of the activity of the industry that we're doing.
Sí, es acá. Era acá, ¿no? Sí.
Well, then we have the quality of the effluents and waste generated, the potential risk of the activity. This means noise that can cause the industry, fires, explosions, and the dimension of the plant, how much space we use, and the location of the company, which is related to if it is located in an industrial area, rural area, or in an urban zone. So, after an analysis that we also will explain later in the Spanish part, we have a score of for these 5 factors, and we got a total score of 42 points, which means that our company is a 3rd category establishment. So this is the end.
Terminó la parte en inglés.